Assalamu alaikum, everyone. Good afternoon to the EE seminar. Today we have Dr. Ahmad Alfaifi from KACST. And before we introduce the speaker to you, just few housekeeping items. So the seminar will be from now until 2 p.m., not 3 p.m. It is by mistake written in the flyer to be 3 p.m. So we have about 50 minutes. And the session or the talk will be divided into two sessions. So the speaker will introduce the topic for the first 30 to 40 minutes, and then we'll have a Q&A session. You can write your question in the chat, and they will be answered in the order they are received. If you prefer to ask your question verbally, just raise your hand before the Q&A session, so you'll be given the chance to ask your question verbally. Okay, so let me introduce the speaker to you. We are glad to have Dr. Ahmad Alfaifi with us today. He is the General Manager of the Saudi Semiconductors Program at KACST. Dr. Alfaifi received his bachelor degree from KFUPM in Electrical Engineering, 2005. He got his Master of Science from University of Michigan, Ann Arbor, and his Ph.D. from McGill University in 2018. His research interests are in micro-electro-mechanical systems or MEMS, and also micro-fabrication. Please join me to welcome Dr. Ahmad, and the floor is yours.
Thank you, Dr. Yaqub, and welcome everyone. So this topic, it's very interesting, and I'm very glad to be with you, let's say, as an old student at KFUPM and alumni. So as Dr. Yaqub mentioned, so today it's about the talk. It's about the kingdom's path toward localizing the industry, the semiconductor industry. So first, let's start with a context about the industry global, and then we'll talk about the local R&D and talents development path, and then the options to localize the industry. Just we'll talk about localizing the industry in brief, because it's at a much higher level than our level at the moment. But let's start with the importance of the semiconductors. You know that semiconductors are the backbone of the many applications that we use in everyday life. So in automotive and communications, consumer applications, data processing, industrial and military applications. And to make it even more important, the next generation disruptors in these applications relies more on semiconductors than they ever were. So, the autonomous vehicles, they are now becoming a trend, especially in the United States. As of now, we can see the cars or the electric or the autonomous vehicles, or even the cars that we use in our everyday life, as a moving computers. They use lots of chips, electronic chips, that roughly 40% of the car price is just the electronics. We can say the same about the communications, the Internet of Things, and the 5th generation of communication. Also, the 6th generation is coming. We don't want to say around the corner, but it's expected in this decade. Also, the disruptors and consumer applications like the virtual reality goggles and the assisted reality and so on and so forth. In terms of data processing, we can see that it's being used very heavily, especially with the cloud options, and also the new disruptor in this segment, which is the cryptocurrency, even though that it's now declining. But also we are having the quantum computing, which is, it's not semiconductors per se, but it's very really affected by this industry. Also, in terms of industrial and military applications, robotics are becoming more relevant than ever, and they use lots of electronics. So what's if we are talking about what's the major driver for the economies around the world to focus on this on semiconductors? So first thing is about its technological importance. As I mentioned, it plays a vital role in this technology that I just talked about. They have a strategic importance. The semiconductor industry has become a geopolitical weapon, as we have seen with China since 2019, and also with Russia since the war started in Ukraine. We have seen that they are being sanctioned in multiple industries, but the semiconductors industry is the one that affected them the most, especially China, which is the United States is focusing on hurting China in terms of the semiconductors industry. So now it's becoming the new oil, especially after the COVID-19, and how everybody noticed that it's very important and they cannot rely on other countries just to control their fate using this, let's say, weapon or geopolitical tool. So it's becoming also a new oil for these industries, and they are now trying to localize this industry just to make just or get a little proportion of the cake of this economy built on semiconductors. So we can say that semiconductors represent roughly more than $2 trillion of the world's GDP in 2020. And at every level that you go up in the value chain, or not the value chain, it's toward the final product, then you multiply the product value by 10 times. So what happened, I'll just talk briefly about this one. It's what happened in 2019 and 2020 with the COVID-19. It affected the semiconductor industry and created a shortage. So what exactly caused the shortage? So because of the pandemic, there was a global shutdowns for the production facilities, and also the electronics demand soared. You can see that lots of computers, tablets have been sold out at that time, because lots of everyday life started to shift toward using electronics, like distance learning and also distance or office job, like work from home jobs. So this created what we call the bullwhip, which is that starting like the demand supply relation started to ripple, and then which caused like the demand to become more than the supply, just in phase of a future shortage. So before we talk about the industry, so let's identify the components in this value chain. So we have three major components, which is the design, where you design the electronic chips, and then the front-end manufacturing, where you actually manufacture chips at the device level, and then the back-end manufacturing, where you assemble the system, let's say package the devices, test them, assemble them. These all are considered back-end manufacturing. And in the design, you are using IP, which is previous designs or created designs that you want to use toward your future devices. And also you need the design tools. In the front-end manufacturing and back-end manufacturing, you'll need the raw material supply and the equipment, which we saw in China's case, that the equipment suppliers were one of the major things that affected the industry, because ASML was stopped from selling their equipment to China by the United States. But what's about the value added in each segment? We can see in this slide that 50% of the value added in the industry is in the design. 24 or 25% is in the front-end manufacturing. But the point here is the front-end manufacturing, it's the bottleneck in this whole industry. So that's what made this part of the industry very important. So this part of the industry, the bottleneck that I talk about, 30 years ago, it was almost there was a monopoly, and most of the electronic chips were manufactured by three economies, which is the United States, Japan, and Europe. But that has changed ever since, and now all of them, they are now less than or about 30% of the global manufacturing capacity. That shift in the capacity was to Asian countries, Taiwan, Korea, and China, was caused by the business model that the United States adopted, which is the fabless model. So they wanted to focus on the designing rather than manufacturing chips, because it's very like the cost is very high in the manufacturing and the revenues are more in the design. So they decided we should focus on the design and leave the manufacturing to other countries. But now, because of COVID, and also the political tensions with China, the United States has realized that they made a huge mistake, and now they are trying to bring in this industry, like the manufacturing industry, onshore. So, and it's not the only one that's doing so. So we have almost all the major players. They are trying to make themselves stronger and support their industries. So we have seen the Chips for America Act that was approved a few months ago. It's supporting this industry with the $52 billion over 5 years. There is a European Chips Act that's being discussed now. They want to increase their market share to 20% rather than 8% as of now. And they are also depositing or like preparing huge amounts of money just to realize this target. China has started in 2015 on this plan. It's called Made in China 2025. And they achieve their plan in semiconductor is to achieve 70% self-sufficiency. And they are planning to invest $150 billion over these 10 years. Now we are having a similar movement by Japan and Korea and also Taiwan. They are also trying to strengthen themselves, in addition to other industry or other economies that are trying to localize the industry, like India, for example. So if we try to go to the value chain and try to study it in depth, we have, if we divide it to the major parts, which is the materials, tools and equipment, design, foundry, and testing and assembly, and then the distribution. So materials, it's just the materials that you need to manufacture the chips, and then the tools and equipment, it's either the one you use to manufacture or the design tools themselves. And then the design, it's the IP and the companies that are doing these designs. Foundry is where you manufacture chips, and then testing and assembly is where you get the chips, and then you start packaging them and testing them, and then giving them to the final distributors. So we have something that's called the IDM, or the Integrated Device Manufacturer, like Intel, Samsung, Texas Instruments, and Infineon. They work on from design up to the testing and assembly. So they work on these three parts. They are called integrated device manufacturers. The ones that work only on design, they are called fabless. The one that manufacture only the chips, they are called foundries. And you can see this industry is fragmented among so many players. If we exclude the IDM or the integrated device manufacturers. But the key country in most of them is the United States. In materials, it's the United States. Tools and equipment, the most critical equipment, which is the lithography tool by ASML in Netherlands. It's also being controlled by United States because also they have the patents and the IPs for some, and they control the suppliers to this company. So we can say that also the United States that controlling that design equipment. It's also the same in the design. Most of the design companies are there in the United States. Foundries, it's the only thing that's missing from the United States at the moment, which is being mainly controlled by Taiwan, or like especially in the leading edge technologies. Testing and assembly, it's you can see that it's like half and half between Taiwan and United States, and the distribution, the most important companies are in the United States. So if we look at Saudi Arabia, so what do we have here in Saudi Arabia in terms of this industry? Unfortunately, we don't have any strong players. We have a few companies like Sami Advanced Electronics. We have Pioneers Factory that both of them, they are active in the back-end capabilities. In terms of the R&D capabilities, we have a few entities that work also on these three segments: design, foundry, and testing and assembly, which, for example, KFUPM, they have the design tools to design chips, and then they can send them for manufacturing, but they don't have the clear room. So we are not the best in the best position as of now. So what's the effect of this one, the weak industry? So Saudi Arabia now, it's one of, if we compare it, for example, to United Arab Emirates, we import and export less electronics or semiconductors than United Arab Emirates. And our ratio, it's very, like most of electronics that we have, they are imported rather than exports. And the reason for that, we can see that we have electronics in our everyday life. So why are we importing so little electronics or semiconductors, and we have this small share in the market? It's because we are importing from the OEM. So we are importing the whole system. So if we look at this chain here, so I'll try to annotate it here. So if we start from the consumer, so the consumer buys the equipment from the OEM, the whole system. This manufacturer assembles the whole system from subsystems, which is called tier 1. And these subsystems are assembled from the components that are packaged, which is called tier 2. The suppliers are tier 2 suppliers. And then the remanufacturers of chips or the wafers are the tier 3 suppliers. So we don't have any tier 3 supplier, no tier 2 supplier, very few tier 1 suppliers. So that's why we are very weak in terms of this industry, as in terms of import and exporting. So what do we need to localize it? So there are 4 pillars to localize this industry. First one, it's the technology. You need to have the technology to manufacture, to design. If you don't have the technology, then you don't have the industry. That's what happened to China, and it realized that because of this, it will be sanctioned. And they worked on this long time ago. So now they are trying to localize everything in this industry, from materials, equipment, design, manufacturing, everything. They are trying to localize it, but they are still struggling as of now. Next thing is the human talent. So you need to have human talents who are capable of localizing the industry. So if you have factories, for example, and the fabs or foundries, and you don't have the human talents, then it's not going to operate itself. So you need this human talents to be developed locally. If you are trying to bring them, or like, let's say most of them from outside the country, then you don't have this industry. Also, you need incentives and regulations. This industry, it's very expensive, and it needs a lot of incentives in terms of tax cuts. And we can see that in China's case, they are giving lots of incentives to Chinese companies just to kickstart this industry. They're giving them land, free land, lots of tax cuts for a few years. They don't have to pay taxes, and so on and so forth. So also we need to have investments and infrastructure. So we need to support this industry. As I mentioned, it's very expensive. Companies, they cannot localize this industry by themselves. You need the support from the government. Also, this industry, it's very sensitive to the infrastructure. It consumes a lot of electricity, especially in the foundry, and water. So you can't talk about thousands of liters of water every day. And in a country like Saudi Arabia, where we don't have huge supplies of fresh water, then this is it's a huge problem. So we did a study, and we here at KACST, and just to try to set what shall we do in terms to localizing the industry. So there is it's no brainer. Like the technology of human talents, that's one thing that we as research and development entities and educational institutes, this is our part. We need to develop the technology. We need to develop the human talents. So this is why we created the Saudi Semiconductors Program here at KACST. I'll talk about it shortly. And then also, in order to develop the industry itself, you cannot do as China did. Like they are trying to localize everything. We cannot do the same here in Saudi Arabia. We have limited resources, and also that's not the right. So the best way to do it is to start with a seed, like something that you build the ecosystem around it. For example, if we look at Newport wafer fab at UK, it's the largest UK chips foundry or factory. And since they started it, you can see that so many research entities and suppliers and like industries, they are being built around this foundry. So it acted as a seed for the industry just in one city. So imagine what you can do if you have more foundries, or if you are trying to diversify your value chain or supply chain, things like localizing also the design. So let's I'll talk shortly about the Saudi Semiconductors Program, which is meant to localize the R&D in the kingdom. So first, it's what's the Saudi Semiconductors Program? It's the local multi-project wafer. It's MPW or MPW. So if you want to manufacture chips as a researcher or as a scientist, you cannot buy a whole wafer. The whole wafer, it costs hundreds of thousands of dollars. So you just buy a small area on this wafer, and the companies, or like this arrangement, or the MPW, it's an arrangement. So they collect multiple designs and then send them for at once to fabricate them for the whole researchers, or for multiple researchers at once. So you just reserve or book like a few millimeters, a few square millimeters, and that's it. It's the whole area that you need. So first we benchmark just to know what we shall tackle in this program. We benchmark with what other economies that are advanced in this industry, what they are doing. So most of them, they are providing the design tools and supporting or subsidizing the manufacturing or front-end manufacturing, so the chips manufacturing. And also some of them, or most of them, they help in the back-end manufacturing. Some of them, they provide also training on the design or the manufacturing, and also they have some webinars. I don't know if you have attended some webinars in the SSP, but we tried to mimic what they did here. So after we launched the program, it was in March 2013, and the Future of Semiconductors Forum that we held here at KACST, and it was organized by KACST and KAUST and Research Development and Innovation Authority. So we launched this program by His Excellency Dr. Munir Deshoghi, which is also an alumni of KFUPM. So just to mention here about something, we are also having the second forum here this year. It's not here at KACST, but it will be at KAUST. So if you're interested in attending it or giving talks, so maybe just give me a heads up. So what we are doing here at in this SSP, so we are trying to support the advanced R&D in international foundries, and also in the basic research and education here at KACST facilities. So in terms of the advanced R&D, so we are still trying to build this track, but we have everything there ready. It's we have the foundry that's gonna fabricate the chips. We have everything ready. Just a few issues that we need to resolve before we kickstart this track. But in terms of basic research and education, we have already started it. We have started just a test shuttle this month. So this test shuttle, for this test shuttle, you need shuttle. What we mean by shuttle, it's the fabric. Like if you want to fabricate chips, you don't send them when you are done and then expect them to be fabricated. So there is a timeline for fabrication schedule for every year. So for example, this year we had 23rd of November. It will be the deadline to receive the designs for this shuttle, and then we will start fabrication. So what we did here at KACST, we developed a process for on-MOS process. It's not a full CMOS process. So what we will have are mostly NMOS devices, and then a few passive components like resistors and capacitor and just like the interconnects. So we tested it and it was working, and we were ready just to give it a test with some universities. So it started with KFUPM. KFUPM, some of the students, they have sent us their designs, and now it's in the pipeline. We are fabricating the photomasks, so we can start the process or fabrication process, the actual fabrication process, hopefully in 2 weeks or less. Also, they visited us, some of them, and we're very glad to have them here just to be exposed to the process and how complicated it is. So I think they spent just one day here at KACST and our clean room, but to finish the whole fabrication, it will take you roughly 1 to 2 weeks just to finish the whole process if you are like trying to do a marathon and finish everything really fast. So here you can see them in the yellow room where there is the photolithography, or the most sensitive step in the fabrication. So now we are done with the R&D. We know what we need to do. We need to develop the human talents. We need to develop the technology and the prototypes. So what about the industry? How can we localize the industry in Saudi Arabia? So if we look at this value chain, so there are different segments where we can try to tackle the materials to the equipment, design, foundry, testing, assembly, and distribution. So which one shall we try to tackle first, or make it as a seed for the industry? So there are different cases for each one. For example, the barriers to enter, it's the materials here are very, they need to be very, very pure. So we need to have extremely excellent refining capabilities, and you have to have very excellent advanced R&D. So we have the materials here in the kingdom, but it's in terms of R&D, it's medium, so we cannot start there. Those equipment, it's the same. It's very advanced technology that it's difficult to tackle in the beginning. Design, it also needs lots of years just to start building a company and the design. So you'll need multiple years just to try to build the team and then create some IPs. The foundry, it's capital. It needs huge capital investment. So that's one of the things that we can tackle at the beginning, and it does not need like a huge R&D in the beginning. So, but the capital investments are very huge. So that was one thing that we is considered as high entry, or like possible to enter. But the problem in this foundry, it's very consolidated. Like you cannot develop the process by yourself from scratch. So you need to transfer this process or knowledge from a partner or like international partner. But the industry is now being consolidated, and it will be very difficult to enter this industry if you don't have the right partner with the right technology that you will need. Testing and assembly, I believe maybe some of you have seen Al Azlan, they are trying to localize this part. It's not difficult, but it's in terms of labor, it's doable, but it's not, doesn't give you like high value added in this industry. And also it's the same in distribution. So we think the materials, design, foundry are the right candidates, but which one shall we tackle? Just this is it's above my pay grade to what we did like to determine or to explicitly say it, but it's being now discussed in the government at high levels. As you know, there are multiple giga projects in the kingdom, and like Sir Law said, they are trying now to localize manufacturing roughly 300,000 cars each year, and there are also giga projects like the Line, Neom, and Hexagon, and all of these projects they'll need so many chips, which if you are trying to rely on foreign supplier, then it would be you'll not have the strategic leadership in these industries, and you are risking these huge projects to fail just from at any moment. So I think this is a hint where I think the kingdom is going on. It's not the materials, so the design, it's still we are trying to build it. Also, there is an initiative to build the capability in the design, but it's not. It will take time to build it, like 5 at least to 10 years to have a decent design house in Saudi Arabia. So I think I'm out of time as of now. I hope that I give you just a brief introduction on how we see the industry. This industry is being localized in the kingdom. If you have any questions, then I'll be happy to answer them.
Well, thank you, Dr. Ahmad, for this nice presentation and excellent information. It is. I mean, you put us actually in the right position now to know what is going on about the semiconductors industry and possible direction for this industry. So we got some questions in the chat, if you allow me to go over them. So we got one from Ahmad Al-Quraishi. He thanks you for this excellent presentation, and he's asking about is there any society for researchers interested in semiconductors? This is one. Second, he's asking about what can KACST through SSP program provide for the research or the researchers in this field.
So regarding the first question about the society, I don't think we have the society as of now, but we are trying, like the SSP, we are trying to make it as an alliance between universities and make everybody that's interested in semiconductors design, manufacturing, just to utilize the resources that we have at the SSP. Yes, we are not running now at full capacity, but whatever we receive, we try to fulfill. So, yeah, as you mentioned, there is no society, but just keep an eye on like the SSP and the activities at the universities. So, because what we are trying to do now is to build talents at the universities. We cannot build the talents ourselves. So it's the mandate of the universities. So they are the ones who are gonna direct you to whatever we have and will be beneficial for you as a researcher. Also, what we can provide with you. So we are trying to now to prepare the training programs that will prepare the engineers and scientists to use these technologies, or just to get familiar with them. And so if you need to get training here at our clean room, you are more than welcome. You can just, we have Dr. Yaqub, he is our contact point at KFUPM. So we can arrange a visit if you want, or if you want to come in a co-op training, just to spend more time in the clean room. It's very time consuming, and it's very interesting, and you'll enjoy it a lot. Like once you enter the clean room in the morning, you're like, in no time you'll just notice that it's 5 p.m. because you enjoy your time there. So these are the two things: the training, the online, like the training on the design and the fabrication. We'll try to give you as soon as possible in terms of the design. The fabrication, you can just contact Professor Yaqub and arrange a visit to our clean room, and we'll gladly help you there.
Okay. By the way, thank you, Dr. Ahmad, the team for inviting our students for the clean room. It was very informative for them. And by the way, is there a website for SSP? So anyone interested to know more about the SSP and what it provides, and also maybe if they want to submit a design for a shuttle, is there any plan to do such thing?
Yeah, so we have the design. The website is almost ready, but we don't want to launch it until we have everything in place in terms of the processes and training, because these two things are the major or pillars of this SSP. So once we have the process verified and it's ready to be used from our side, and also we have the training programs that will help the beneficiaries to start designing, then we'll launch it. So hopefully within from now to maybe the next forum that I talked about, that will be held at KACST. It will be in May. So from now to then it will be launched, and but it will be just for get the tools, like to book the tools or the processes and get the training. It will be the major things that will be provided in the website at its launch.
Okay. So we got a question from Dr. Ayman Al-Melh. He's the chairman of the computer engineering department here at KFUPM. He said we have a concentration program. I think we talked about this one, Dr. Ahmad, previously. He's asking whether you recommend this concentration or this field to build a program, a concentration program, and also what courses should we think to offer in this program? Maybe what ADA tools can KACST provide for us or for other universities as well. So it's like a 3-in-1 question.
Yeah. So something that we have discussed about this industry, like localizing in the industry. So we the most important thing, it's the human talents. So what kind of human talents are we looking for? So we are looking for everything, like from bachelor to master to Ph.D. So what are about the majors? So in terms of analog, you'll see that they will be mostly from electrical engineering department. But when we go to the digital designs, then computer science and computer engineering, we'll have the upper hand there. So yeah, I totally think that you should focus on the VLSI courses, the digital design courses. I'm not familiar with this in this field. My background, it's more in the MEMS or closer to the analog design rather than the digital. But I know that the VLSI, I remember that VLSI was introduced in the past, at least at KFUPM. And in terms of the design tools, so that's one thing that the digital designers, they do not need, maybe they'll need Cadence at some point, but the open source tools, they are also, I think, extremely good to be used for digital designs. If we are talking about the VLSI from computer engineering, like OpenLane and other software that are recommended. Maybe if you go to eFabless, they are one of the companies that provide this service worldwide. They recommend some open source tools. One of them, I remember, it was OpenLane. So even if we are now trying to provide the tools, but it's a legal issue rather than a financial issue, because we cannot sign agreements with companies that resolve disputes outside the kingdom. So that's the only thing that is stopping us from giving you the tools. But hopefully this one will be solved maybe in the next few months, especially with Cadence. So once we have solved that issue, we can provide the researchers and students access to Cadence. But I know that Professor Yaqub and the Director of Engineering Department, they also have access to Cadence. So, but other than that, maybe we can help you in the manufacturing itself, either here at KACST or at the international foundries, for example, Skywater or Global Foundries and their open source, their open PDKs.
Okay, thank you, Dr. Ahmed. Also, again, Dr. Ayman is asking about, and this is very important actually question. It's about what will motivate the students to specialize in this industry. I mean, there is no, at least for us now, there's no clear job market for fresh graduates in semiconductors here at Saudi. So I'm not sure if you can comment on this, elaborate more in the job market, what can motivate the students to go for this industry or this direction?
Very excellent question. So, it's almost as the issue like which comes first, like the industry or the talents, the egg or the chicken. So we had this discussion with Capgemini. It's one of the biggest consulting companies in terms, or like engineering R&D companies in terms of chips designs. They're recommending that we start with the talents first, because like for the industry, when it comes, it will need talents in huge numbers. They're asking how many talents they graduate from Saudi Arabia each year. What's the pipeline for these talents? And the number is modest, something like if we say that, for example, at KFUPM, maybe something like 20 each year. Some other universities, maybe 5. So if we combine them, we'll have less than 50 at best case scenario. They'll need more than 100 each year, which is more than what we can afford at the moment, or like offer, like from our educational institutes, all universities in Saudi Arabia, because not all of them teach this specialty. So most likely we'll depend on a few universities like KFUPM, KSU, maybe King Abdulaziz University, King Khalid universities, don't know, maybe Qasim universities. Some of them, they have this concentration or this area, but not all of them. So the demand will come and it will be huge. So even if you have few courses or if you just spend your senior project in this field, it will be it will make big difference for, and that will differentiate the students graduating with this experience from other graduated students from other universities around the kingdom. But yeah, we'll need lots of human talents that are exposed to this experience.
Okay, we have a question from Imran. He's asking about the SSP program. What are the plans for training and talent building or capacity building and so on? I think Dr. mentioned some of that. So if you want to add something to this. discussing?
So we have almost everything ready and in place. It's just more like an administrative issues that are still holding us back because now as the strategy for the program, we just need to finish the strategy, and then approve it by the committee. We have a steering committee, and KFUPM, one of the members or the faculty members at KFUPM is in the steering committee. So once this strategy is approved, I think we can go ahead and start the training programs, but we cannot, unfortunately, we cannot start the training while the strategy is not approved, because there will be a question about why did you do this step? Why did you choose training program in this technology itself rather than other technologies? So we need just to convince the steering committee that we are doing this based on our capabilities and demands, and then we can go from there. But yeah, we were expecting to launch the first training program in December, but we are now holding it back to 2030, and in terms of the design and online training. If you need any training in our clear room, then by all means, at any time you can visit us, and we can help you in that regard.
Okay, so I think we still have two more questions. Yes, so one of the audience asking about the private sector partnership with the SSP. Is there any kind of partnership with the private sector?
Yes. So also we have two private sector members in this steering committee, which is Aramco and Sami Advanced Electronics. Mm-hmm. So also we are trying to capitalize on what they have and try to see how we can utilize what they have. For example, here we have our clean room here in KACST in Riyadh. Maybe it's not very convenient for students from outside Riyadh to come here and get the training, but we are trying to get something for students from around the kingdom. So, for example, Aramco, they have Lab 7. I think they are also trying to localize what we call as a minimal fab technology. That minimal fab technology, it's similar to the clean room, but you don't need a clean room. So you can fabricate chips in just a regular lab. I believe Aramco is going forward with this, or acquiring this technology. I'm not sure if they can provide it to the SSP, but that's what we are trying to get from them. We're asking them, what can you do for us as a SSP? Because in the SSP, we don't want something for ourselves. We just want something for our beneficiaries, like the students from around the kingdom. So that's what we are trying to get from every member in the steering committee. We are asking them, how can you help us in the SSP so we can help the students? So that's one thing of Aramco. Advanced Electronics, they are very keen to give projects that the students can design. For example, if they have certain project with certain specs that they can give you the specs and you as a student, you can start designing a system, either assembling using electronic off-shelf components, or you can if you can design the IC itself, but I believe it's still very early at this time. So these are the two private sector that we are trying to collaborate with. Unfortunately, we don't have a strong private sector in these industries that can help the SSP, but hopefully in the near future we can have more with this. Another thing, it's one of the private sector. It's Ajlan Group, Ajlan Brothers Group. They are providing, or they are offering a prize, but it's still now being discussed for researchers and achievements in semiconductors industry. They are still discussing what are the criteria, but it will be for the semiconductor. It's meant to enable and support the semiconductors industry in the kingdom, and mainly, and also the users of the SSP.
Okay, I think with that, Dr. Ahmad, it's about time to close the talk. Thank you very much for this talk, and it was very informative. And maybe one advice to my students or all students here in the audience, it's a really good time now to jump in and join this kind of movement for the semiconductor industry, whether it be design, front end, back end. You will be among the first generation of this technology in Saudi Arabia. Thank you all for your attendance. Thank you, Dr. Ahmad, for the presentation.
Thank you. Thank you all. Thank you.
Thank you very much, Doctor.